Hi friends, this is Ramesh sir, Physics. So welcome to our session and welcome to our channel. Today we are going to discuss about human and colorful world. So just close your eyes children. Can you watch the beautiful world around you? You can't see because of the eyes playing very important role to see the beautiful world around you. And sometimes we are unable to see the far distance object, sometimes we are unable to see near object because some defects are going in our eye vision. So today we are going to discuss about what are the defects are going in our eye vision, how do you correct them in our eye vision. These are very important in our day-to-day life also, and the chapter also important in the examination purpose also. So let us discuss what are the solutions of the previous questions. The lens that is used to rectify hypermetropia, so that is convex lens. What is that? Convex lens. So why we have to use the convex lens to correct the, what is this? Just hypermetropia. You see children, so the object is between just near point and least distance of the distant vision. The object is between H and O. See, the light rays are coming from the object, fall on the convex lens. So then what will happen? Convex lens form the image of this object at so near point only. Then what will happen? So this is act as a object to the convex lens. Then the image of the object will form on the retina. What? Retina. That's why. So we have to use the convex lens. What children? Convex lens. So second option is the correct option. The relation between the speed of wave V, wavelength lambda, and frequency n. So we have one formula. What is that formula? So the speed of the light is V and the frequency of the wave is n and the wavelength is lambda. So from this equation we can write lambda equal to V by n. Lambda equal to V by n. So we have to use this formula. What is the formula for speed of the light? Speed of the light V equal to n lambda, where n is the frequency of the light, lambda is the wavelength of the light wave. From this equation, lambda equal to V by n. So fourth option is the correct option. Next, when object of different distances seen, which of the following remain constant? So focal length of the eye lens, object distance from the eye lens, image distance from the eye lens, the radii of curvature of the eye lens. So when object of different distances are seen, which of the following remain constant? So actually, so children, which is the constant? The image distance from eye lens will be always constant, because so when we are seeing long distance object and short distance object, the image is exactly formed on the retina only. That's why the distance from eye lens to and the retina always will be just 2.5 centimeter only. What is that? 2.5 centimeter only. Because of when you see far distance object, image formed on the retina. When you see near object, image formed on the retina. Because the eye lens, it has the accommodation ability. That's why the distance from eye lens to this image always will be 2.5 centimeter only. That's why image distance from eye lens always will be constant in the just healthy human eye. What is that? Healthy human eye. Next, the focal length of eye lens change between these values. What are the values? That is 2.27 centimeter to 2.5 centimeter. 2.2 centimeter to 2.5 centimeter. How it is possible? Let's say infinity. So you can write 1 by V. 1 by V means so V equal to 2.5. So minus 1 by infinity. You write on infinity. So 1 by F equal to 1 by 2.5, because 1 by infinity equal to 0. From this equation we can write F maximum equal to 2.5 centimeter. 2.5 centimeter. So when you see the long distance object So the focal length of the eye lens will be 2.5 centimeter. 2.5 centimeter. Suppose if object is at least distance of the distinct vision, then so 1 by f equal to 1 by v. So 1 by v means, so we can write 1 by f equal to 1 by v means 1 by 2.5 minus half minus plus will come 1 by 25. So we can write 1 by f equal to 1 by 2.5 means 10 by 25 plus, so 1 by 25. So 1 by f equal to 11 by 25. F equal to 25 by 11. F equal to 2.27 centimeter. This is the minimum value. What is that? Minimum value. Therefore, so when you are seeing far distance object, what is the focal length of the eye lens? That equal to just 2.5 centimeter. And when you are seeing object at least distance of the distinct vision, the focal length of the eye lens will be minimum 2.27. Therefore, we can understand that the focal length of the eye lens will changing from or between 2.27 centimeter to 2.5 centimeter. So we should not by heart, we have to follow the equation. By the following equation, we can prove it also. Okay, children? Right. What is the minimum and maximum focal length of the eye lens? 2.27 centimeter to 2.5 centimeter. Okay, children? Right. Next, unit of power of lens. Unit of power of lens. So we have the formula. What is the formula? Generally, so power P equal to 1 by f, where f is the focal length. The reciprocal of the focal length is called power. What is that? Power. Generally, the power is measured in terms of diopter. What, children? Diopter. Therefore, what is the correct option? So 3 is the correct option. What is the, children? 3 is the correct option. Next, we are going to discuss about some problems also. The near point of an just elderly person is 50 centimeter from the eye. Find the focal length and the power of the corrective lens that will correct his vision. We have to find the focal length and power. First, we have to draw the diagram, children. The near point of an elderly person is 50 centimeter. So here, just you have to draw a small diagram, children. So this is the least distance of the distinct vision. This is the H means near point. So they give here image is forming here. Here image is forming here. That's why. So here we can take V equal to minus 50 centimeter and L equal to how much? L nothing but U. U equal to minus 25 centimeter. Find 1 by F equal to 1 by V minus 1 by U. So 1 by V. 1 by V means 1 by minus 1 by 50 minus of 25 means 1 by 25 coming. So here 50 into 25. So 50 get cancelled. So here minus 25 will come. Next plus 25 cancel. Here 50 is coming. So 1 by F equal to, so 50 minus 25, 25 by 50 into 25. 25 1 ja, 25 2 ja. Last, you see power P equal to 1 by F. So where if you take here 100, where F in the centimeter, therefore 100 by 50, 51 ja, 52 ja. So P equal to what is coming? Plus 2D will come. What is coming? Plus 2D. Because of 100 by 50, 51 ja, 52 ja. So what is the unit of the power? Diopter. So you should take 2D. D means diopter. So here we are getting positive value. So P equal to plus 2D. Next question. Image is formed for the short-sighted person at retina, before retina, behind retina, and image is not formed at all. Short-sightedness. What is the meaning of your short-sightedness? Nothing but myopia. What is that? Myopia. Myopia means a person able to see near object but cannot see long distance object is called myopia. What is the main cause for formation of myopia in the human eye? Because of the image is formed before retina, in front of retina. You take this diagram, you see the the tree is, suppose tree is the object. The object is at infinity distance. Suppose you take a tree, it is at infinite distance, very long distance. The light rays are coming from the tree and those are refracting through these islands. Then what happened? The image is formed in front of retina. Actually, the image should formed on the retina, but the person has the myopia. Due to myopia, what happened? The image is formed in front of the retina. So if the image is formed in front of the retina, the person able to see front object, near object. He cannot see far distance object. That's why image is formed for the short sighted person. That is what is that before retina. What children? Before retina. You see this example. The light rays are coming from the tree and moving parallel to the principal axis. After refraction, they converge into before retina. So here image is formed before retina. That's why which is the correct option? Before retina is the correct option. Next, color blindness. See, the defect of the eye caused by the old age. One is color blindness, myopia, hypermetropia, presbyopia. So it may be answer. So presbyopia. What is the meaning of presbyopia? So presbyopia means as the age of the person increases, the ciliary muscles are become very weak. Therefore, the person cannot see the very near object. He is suffering from to see the near object. That is called presbyopia. So fourth option is the correct answer. Next, the ability of eye lens to change its focal length called focal length of a lens. Next, focus of a lens, magnification of the lens, accommodation of the lens. Already we have discussed, children. What is this? So when you take eye lens, if object is just object is at infinity, is at infinity distance. So what is the focal length? Focal length is maximum, that is 2.5 centimeter. And if object is at suppose u equal to 25 centimeter, then the focal length is minimum, that equal to 2.27. So here what is going? The eye lens is changing its focal length with the help of the ciliary muscles. Because when you see long distance object, the ciliary muscles are getting relaxed. Therefore, maximum amount of the light entering into our eyes, focal length increases. Then the focal length will be maximum 2.5 centimeter. When you see the near object, the ciliary muscles are contracts. Therefore, minimum light only entering in our eyes. That's why the minimum focal length will be 2.27. So, in what is the greatness of the eye lens? The eye lens can adjust its focal length with the help of the ciliary muscles. That's why the adjustment of the focal length of the eye lens is called accommodation. What is that? Accommodation. Otherwise, the ability of eye lens to adjust its focal length is called accommodation. So, fourth option is the correct option. Okay, children? Right. The distance between the eye lens and the retina of a healthy eye. So, that is always 2.5 centimeter. What is that? 2.5 centimeter. Why? Because, so just to take one example, healthy human eye, suppose if the object is far distance, so exactly image is formed on the retina. Therefore, the distance from eye lens to, so this image distance V, so that equal to how much? 2.5 centimeter. If object is near also, the image is formed on the retina. So from the diagram, what understanding? Though the object is very far distance, image is formed on the retina. If object is somewhat near, image is formed on the retina. What is the meaning of distance of the image? The distance from eye lens to this image is called image distance. The image distance always will be 2.5 centimeter. Thus, for a healthy human, the distance of the image always will be 2.5 centimeter. Therefore, the option will be 3, that equal to 2.5 centimeter. Next, hypermetropia can be corrected by using dash lens. Already we have discussed in the previous class. So we have to use the convex lens. What the convex lens? Okay, right. Convex lens. Next, the far point of human eyes. Far point. What is the meaning of far point? Far point nothing but a point of maximum distance at which the eye lens can form image on the retina is called far point. Best example you see when you see the sun. Sun is at infinity distance, but the image of the sun can form on the retina. Therefore, the sun is at infinity distance. Therefore, we can understand that the far point of human eye is how much children? That is infinite distance. So fourth option is the correct option. Next, the size of the pupil of the eye is adjusted by. So you see children, iris. Iris is the correct option because so when you take the human eye children, you see this is the eye lens. So here what is there here? A diaphragm structure is there. This is called iris. This is called iris. So the midpoint of the iris is called pupil. What is that? Pupil. So here the iris can control the size of the pupil. Therefore, we can understand that the size of the pupil of the eye is adjusted by iris only. What Nana? Iris only. Let us see. Plus 50 cm focal length biconvex lens is recommended to correct the defect of vision of a man. Find the power. Nothing is there children. A doctor is suggested. So plus 50 cm of the focal length to one person. You have to find the power of that lenses. So here only they give. So here f equal to plus 50 centimeter. F equal to plus 50 centimeter. We have to find the power equal to question mark. Power equal to question mark. So we know that power P equal to 100 centimeter by 100 by F in centimeters. F in centimeters. So you write 100 as F equal to how much? 50. 50. So 51 ja, 52 ja. So P equal to plus 2D is the correct option. Which is the correct option? So plus 2D is the correct option. So they are giving. Sometimes they are giving focal length of the lens. They are asking power. So we have to find power P equal to 100 by F. If F is in the centimeter. F is given centimeter. So we have to use this formula. Okay na? Right. So P equal to plus 2D km. This important point. Suppose F equal to plus 50 km. F equal to plus focal length is given plus. It indicates that you have to understand that is called hypermetropia. Hypermetropia. The person suffering from hypermetropia. Then he has to use which lens? He has to use biconvex lens. What is that? Biconvex lens. So based on the sign of the focal length also, we can find what is the defect of the eye vision of the person and what kind of lens he has to use. Suppose f equal to plus k, focal length equal to positive k. Positive means that is biconvex lens and the defect is called hypermetropia. Next, far point of a myopia person is 40 centimeter. What type of lens should he wear so as to see the distance object clearly? Find the focal length, power of the person. Far point of a myopia person is 40 centimeter. So here, so we can take here how much? So here V equal to minus 40 centimeter. Next U equal to infinity. How much children? Infinity. So we have the formula. What is the formula? 1 by F equal to 1 by V minus 1 by U. So right, 1 by F equal to 1 by V. 1 by V means minus 1 by 40 minus of minus 1 by infinity coming. So here last F equal to minus 40 will come. Minus 40 centimeter. We have to find power. So power P equal to 100 by F in centimeter. You write 100 by F equal to how much? Minus 40. 0, 0 get cancel. 4 1 ja 4, 2.5 ja 10 will come. So here P equal to minus 2.5 D. So which is the correct option? Option 1 is the correct answer. So minus P equal to minus 2.5 D. Nothing but F equal to minus 40 came. If here F is plus, that is called hypermetropia, we have to use biconvex lens. But here you see, F equal to minus came. If the focal length is negative, so that is compulsory, we have to use biconcave lens. Biconcave lens. Then what is the defect? That is myopia. What is that? Myopia. That is called myopia. Therefore, based on the sign of the focal length also, we can justify whether that is a myopia or hypermetropia, what kind of lens we have to use for the correction of the eye vision. Next, find the power of a lens of focal length here 100 centimeter. They give direct. So here you see F equal to, they only give 100 centimeter. Power P equal to, what is that? 100 by, so F in centimeter. 100 by F equal to how much? 100. Get cancel. So P equal to how much come children? P equal to, so here 1D coming. Which is the correct option? First one is the correct option. What is that? First one is the correct option. So from this equation we can understand. Suppose P equal to 1 by F, where F in meters. Sometimes they are giving questions direct also. P equal to 1 by F in the meters. Suppose one example is there, children. The doctor suggested to patient using of, suppose P equal to, so 2D lens. So find the F value. F equal to question mark. So based on the, so P value, we can find the F also. What children F also? You see P equal to, they give 2. You write 1 F. So then we can write F equal to 1 by 2. 1 by 2 means that is 0.5 meters. So nothing but that equal to 50 centimeters also. Okay children, I am requesting please like and share and give the comments to this channel. The eye defect is shown in the figure. What is the name of defect? They give diagram, we have to find the answer. What is that? Myopia, hypermetropia, presbyopia, no defect. You see the diagram given, you see Nana. So here one object is there children. The light rays are coming from the object, so and refracting through the eye lens. But what happened? So they meet behind the retina. Here retina is there, but the image is formed behind the retina. So do you already know children what is the meaning of hypermetropia? Hypermetropia nothing but a person able to see far distance object, cannot see near object. What is the reason? Because of if the image is forming behind the retina, that is called hypermetropia. So according to the diagram, the image is forming behind the retina. Therefore, it is called hypermetropia. What is it children? Hypermetropia. Next, which part of human eye is called variable aperture? Variable means changing. Aperture means so the surface area on which light is getting reflection is called aperture. Variable aperture. Generally, so pupil can be called as variable aperture. Why the pupil can be called as variable aperture? Because you see children, so here this is iris, so the midpoint of the iris is called pupil. So when the large amount of the light is enter in our eye, so the pupil contract because size decreases. And when you go to the dark places, so the size of the pupil increases because it allows the large amount of the light. Thus the size of the pupil changing according to the intensity of the light. That's why the pupil can be called as what children? So a variable aperture. So third is the correct option, pupil. Next, Raman effect is related to which phenomenon of light? Refraction, reflection, dispersion and scattering. What? Scattering. So actually the Raman effect mainly belonging to the what? Scattering. What children? Scattering. What is the meaning of the scattering? Scattering nothing but when the light is incident on the any atom, then what happen? This atom observe the light, then it emit the light in all over direction. That is called scattering of the light. So based on the scattering of the light, the Sir C.V. Raman could explain the why the sky in the blue color and why the ocean water in the blue color. That is depending on the scattering only. So scattering is the correct answer. Okay children? Right. Next, if you want to understand scattering, you take some rice. Just pour the rice on the floor. What happened? The rice particle moving in the different direction. That is example of the scattering of the particles. Next, least distance of distinct vision for normal eye, that equal to 25 centimeter. What is the meaning of this least distance of distinct vision? Suppose example, so if you wanted to read the information given in the textbook, by keeping very near, our eye is getting strained. And if you keep the book very far distance from your eye, you can't read the textbook. Suppose if the book is at 25 centimeter, what will happen? So we can see the object without getting any strain also. So here what is the meaning of the least distance of the distinct vision? So the minimum distance at which the object is appearing very clear without getting any strain and stress to the human eye is called the least distance of the distinct vision. That equal to nearly 25 centimeter. So 25 centimeter is the correct answer. Which lens is used to correct myopia? So that is concave lens. What is that children? Concave lens. You see one example, concave lens. Why we are using concave lens? The object is very long distance. The object is very far distance. The light rays are coming from this object fall on the concave lens. But what happened? This concave lens form the image of this object between far point and least distance of the distant vision. So here image is formed, but this image act as a object to this concave lens. This eye lens. Then the image exactly formed on the retina. Therefore, by using concave lens, we can correct the myopia. So which is the correct option? Second is the correct option. Next, which part of the human eye contains rods and cones to receive the light signals? You see children, this is a diagram of the human eye. So this is called retina. Actually the retina acts as a screen in the camera. When the light signals incident on the retina mainly consists of the two kinds of cells. So first one is the rods, second is the cones. Two kinds cells are there. First one is the rods and second is the cones. So these rods and cones just observe the light signals from the retina and they transfer to the brain. The brain interprets these signals, then we have the sensation of the vision. So here, what are the main point? Retina is the correct answer. Which part of the human eye contains rods and cones to receive the light signal? That is called retina. What children? Retina. You see, this is the retina. These are called rods and cones. Okay children? Right. Retina is the correct answer. Next, for a person with myopia defect, the image of the distant object is formed. Before retina, on the retina, beyond retina, none. You see, so when the person suffering from myopia, the object is very far from the eye. You see, the light rays are coming from the object. After refracting through the eye lens, the image is formed before retina, in front of retina. So here, which is the correct option? So here, before retina is the correct option. Okay children, I hope that you could understand. Excellent children. And just you have to read one time, you can give the correct answer. If you watch this video, you can give the correct answer.